David Marçal is a science writer. As all scientists, you have this thing of challenging things and provoking thoughts in people and ideas. And you were actually with us last year at Insights 2018, and you delivered a fantastic presentation on how to lie with data, which was, kind of a shock for some. That's the main reason why we were so happy to have you on board this year again. So please get on stage and enjoy.
Thank you. Thank you very much. It is a pleasure. It is a pleasure to be here. Good morning to you all. It's been a very interesting session. I am a science communicator. I work for the National Science for Scientific Culture, Ciência Viva, and what I do is to write or to produce content about complex scientific issues that a lot of people can understand. I do that for science exhibitions, like interactive science exhibitions, also for radio shows or for publications. And it is not just a matter of waving and choosing some random science curiosities for the public to be impressed. I think the people are already very impressed with science if they think a little about that for a moment. The thing is, most people don't actually know what science is. So to communicate, they may value science, but they actually may not know what science is. So to do science communications is also to talk about how to get data, how to interpret data, how the scientific process deals with data and with the conclusions, and that the science conclusions are not just a bunch of rabbits that we pull out of a hat that comes out of nowhere. So the great challenge is to have people to really understand the scientific process. So in my former life, I'll try to get the right button. I was a research scientist, a biochemistry. I have a PhD in biochemistry. I was a protein crystallographer. I don't know if you ever watched the series Breaking Bad. Walter White was a crystallographer. So being a crystallographer is kind of cool since 2009 when the series has begun. Although unfortunately I do not have his business potential. So, and as you can see for this picture, I used to be a woman, which was great. And although this is a wet lab picture, it is quite a data-intensive field, protein crystallography. It requires a lot of data analysis. I will not talk about that, and a lot of statistics to verify that the models that we build are actually true and are not some coherent fantasy. So I also write science popularization books, such as these ones. And I am the coordinator of the GPS network, which is a network of Portuguese scientists working abroad or that have international careers. We have about 4,000 scientists now in the database. This is not just a phone book, it is also a meeting point for people to, and also a showcase, a way that the Portuguese society can get in touch with these valuable human resources that are scattered across the world. But I will talk today about actually science, data, and how can that be miscommunicated. And when I talk about pseudoscience, which is one of my main interests as a science communicator, I always start with this picture, which is actually a representation of the world from the medieval times, from the Middle Ages. So what we see here is a representation of the world, not a symbol of the world, a kind of a logo of the world. It's how the most well-informed and well-educated people in the Middle Ages thought the world was, which is actually a set of circles with with the central one divided in three: Asia, Europe, and Africa. So this was the representation of the world around this time. But then something fantastic happened. In the 15th century, the Portuguese and the Spaniards sailed across the world and were able to do representations of the world like this. This is very different from the previous. We can tell that it's very different. But the main difference, it is based on observations and experience. The latitudes are marked using astronomical observations, so measuring the height of the North Star or the Sun to see if the boat is further away or closer to the equator. So this is a representation of the world based on observation, based on experience and observation. Also, in the Middle Ages, unicorns were a perfectly normal animal. They were as normal as cats and dogs. Everybody believed they existed. They were not so common. People would acknowledge that, but they were described in the books as real animals. But when Portuguese and Spaniards sailed across the world, the closest thing they encountered to a unicorn was this. So you can say that he's having a bad week, that he has gained some weight, that he's not okay, he's a bit depressed, but a rhinoceros is not a unicorn. So what happened was that the animals that were predicted and were described in the books did not exist, and people found out, sailors that didn't know how to read found out a series of things that were not in the books that no one has ever known about. Actually, this is what started with the idea of new knowledge. So until up to this time, until the discovery of the Americas, new knowledge was not a concept that people had in their way of thinking. They would think that at best they could recover some knowledge of the ancients, like Aristotle's, that have been lost. So in the 15th century, there was a confrontation between two types of knowledge. One that is based on authority, things that are written in very ancient books and that are valued because some very important people say that they are truth, and the knowledge based on experience and observations. This is interpreting books, this is interpreting the nature. The first philosopher that has come up with this idea of interpreting the nature instead of books was Francis Bacon. So, this confrontation, this line, it's actually what separates pseudoscience from science. Pseudoscience, it's mainly based on authority. Some things are truth because some very important people say they are truth. Science is based on observations. It's interpreting the nature instead of interpreting or very old books or very important books or listen to very important people. So this was not solved in the 15th century. Actually, this is a very common problem nowadays, which is the difference between science and pseudoscience. And I will talk to you about one area that there are several areas that are particularly sensitive to pseudoscience. One is, of course, environment. You have already heard about climate change denialists, for instance. Now they are less in fashion, but a few years ago they were taken very seriously by the media and by a lot of people. And of course, health. In the health sector, in the health area, there is a lot of pseudoscience. I have come up with this idea that is very unique. If you think about it, there are no alternative airplanes. There are no alternative airplanes, but there is alternative medicine. And I will discuss briefly why is that. So, unlike medicine, where you have all sorts of complementary, alternative, integrative, whatever medicine, which is, of course, an excuse for bending science or inventing pseudoscience to justify those practices. In airplanes, there's no such a thing. If you think about it, there is not an obsession for traditional airplanes. Nobody says that this plane is great because it has is more than 100 years old. So there is not an obsession for Japanese traditional airplanes. This is a kamikaze airplane from the Second World War. unlike, for instance, traditional Chinese medicine, for which there is an obsession for traditional Chinese medicine. So one of the reasons for that, it's very clear whether a plane works or not. It's actually, the consequences are very obvious. We don't need a lot of data analysis to know if a plane crashes or not. But when it comes to medicine, for instance, in cancer treatment, things might not be so obvious. You need somehow more sophisticated data analysis. For instance, this is a scientific paper that analyzes cancer survival over the course of 7 years, and it compares patients that only do the standard cancer treatment and patients who also use complementary or alternative medicine. So we are not talking about patients that completely give up conventional cancer treatment. We are talking about patients that add alternative treatments to the conventional cancer treatment. And this is the survival rate along 7 years. This is data from almost 2 million patients from the National Cancer Database. And what you can see here is along the first 2 years, survival rates are quite similar. The most differences occur later. So within these first 2 years, these complementary medicine patients, they are satisfied customer testimonials. They will be happy to go on TV shows to tell on every social event or dinner that they are very satisfied with the alternative medicine. They are alive. That would be completely crazy not to do these treatments. Of course, a long time things get a little bit different. And of course, what happens is most times patients that undergo alternative medicine treatments, they also delay the start of the conventional cancer treatments or refuse additional cancer treatments after a first set of treatments. So that was comparing complementary medicine, not alternative medicine. Because if you completely replace conventional cancer treatment for alternative medicine, the survival rate is actually changes dramatically, actually. So it has a much higher mortality rate. Patients that that replace conventional cancer treatments by alternative medicine. But even though, if you think about the first 2 years, things are not always so clear. Although the difference, if you look at statistically, it is clear, the survival rate after the first year, you can see that most people still survive. So this is an area where we need actually to analyze data and understand it in order to see what happened, and not meeting some random cancer patient that is happy because he doesn't do conventional cancer treatments. So why is that? Why is that conventional cancer treatments are so much better than alternative medicine? One reason is that medicine has changed the way it works in the last century. Until about a few decades ago, the concept was the guru doctor that does not actually ask to explain why he decides to apply one treatment or another. For instance, Galen, which was the physician of the emperors, the Roman emperors, said, "I was the only one who revealed the true path of medicine." And he had it. Everyone who drinks this medicine regains health in a short time, except those for whom the treatment is not helpful, who will all die. So it is obvious, therefore, that the treatment fails only in incurable cases. So he had a 100% success rate in curable cases and 0% success rate in incurable cases. This is now a joke, but alternative medicine still works like this. Every time a patient from alternative medicine will die, they will say that he will say something like this: And so what happened was that in the middle of the last century, we started to apply statistical methods to evaluate if a treatment works or not. So, which are clinical trials. So in a clinical trial, you have to do a set of procedures. You have to divide the patients in two groups, and you have to divide it by random. If you don't do that, you'll choose the ones that look more healthy in the treatment group, and the others go to the control group, for which is administered a placebo. So in a clinical trial, for instance, in a medicine that is in a drug that is in a pill. So you give the pill with the active principle to a group of patients, and you give a pill with exactly the same color, the same size, and the same package to another group of patients, but that pill doesn't have the active principle. So you get to see the statistical effect of the active principle. And all of this has to be double-blinded, so neither the doctors or the patients can know if they are in the treatment group or in the placebo group. So the ideal is that you have a lot of clinical trials performed by a set of independent groups. You can analyze the data, eliminating the ones that are flawed in some manner, either because they don't have a control group, that the patients were not distributed along the groups randomly, or they are not double-blinded, or the samples are too small. And then you can combine all the samples of the good clinical trials in the big sample, which is a meta-analysis of data, and you can draw conclusions that are not obviously looking at individual clinical trials. So for instance, this graph represents if a medicine is effective or not. On the left of these graphics means a positive effect, right means a negative effect. So this is the conclusions for individual trials and the error bars. When you add the samples, you start to decrease the error bars and get a more accurate conclusion about, in this case, a very small positive effect. So this is how we know if a treatment works or not, and it has been working. This system has been working very well. That's one of the reasons we are all here alive. So if you go, there is a hierarchy of evidence, and this type of analysis is at the top, which are the meta-analysis of data and systematic reviews. So if you, for instance, have the curiosity of know if acupuncture works, you can search in the Cochrane database, which is a database of this meta-analysis, and see, put your favorite disease and acupuncture in the search box, and you'll come up with one of these conclusions. Acupuncture did not show therapeutic efficacy in the treatment of disease X, or there are very slight indications that it does. So of course, this all lies in statistics. It all depends on having a statistical knowledge, and you can always use statistics to lie, and that's what a lot of people do in several fields. This is a book from the 1950s, How to Lie with Statistics, which points out the tricks that you can use to lie with statistics. And the funny thing is, they are the same nowadays. They are not improved a lot. Just the graphics are different, the design. So for instance, one is the type of average that you use. For instance, if you have a neighborhood and you can say that in your neighborhood the average prices of the house is 1 million euros. That could be true, and that could be good to say if you are selling your house. But you are using an arithmetic mean, so you are summing up the prices of all the houses and divided by the number of the houses. But for instance, if you want to claim for a bus stop in your neighborhood, that might not be a good idea. You have to say that your neighborhood is made of a lot of working class people. So you can say that the average prices of the houses in that neighborhood is 200,000 euros. And that could be true also if you consider the median value, which means that half of the house will cost less than 200,000 euros, and the other half will cost more than 200,000 euros. They are both true, and you can choose one or another according to what you need to convince people with. Another thing is how we represent the graphics. For instance, if you say this is the value of a company in the last year, you can say that his value has has increased by 10%, which is not very impressive. But if you represent it like this, it's already more impressive. And if you change the scale and you represent it like this, it is even more impressive. So you actually can get a very different idea of the value of the company just by changing the graphics, how you represent the data. Actually, this is an actual example from a journalist around the tax revenue in the last few years. One final example, which is my favorite, one of my favorites. If you say that this is the average income, the income per capita in two different countries, you can say obviously that this one has a double, the income per capita is twice of this other country. It is impressive, but if you want to be even more impressive, you can represent it like this, which this side still has twice the height of this side, but the implicit volume of these money bags imply a larger difference than actually the height of the bags, which is actually what you are really representing. So I think I am already in the red light. I thank you very much.
David, thank you very much. Brilliant. We're just so very glad that data manipulation is not used by politicians or politics.